those 3 files. He can read and write those 3 files. But maybe what you're really concerned about is the data that gets written into file 1 could somehow get leaked into file 3, and that would be bad. Maybe that file gets publicly displayed on a web server or something like that. So that would be bad. But the administrator needs to be able to read and write those files. Okay, that's a problem, right? So you could have this data, a Trojan horse here, or even an unwitting user, which is your more likely case than a Trojan horse, could get this data moved over there, and you've got a problem. So you want to come up with a mandatory security policy that prevents that. Well, what we do on the right then to solve that is create subdomains. So the administrator then sits out there, and then he can execute basically small subprograms like SD1. Now, all SD1 has permission to do is read and write file 1. Okay? So if the program in there tries to write anything into file 3, the mandatory policy stops it. And so if the administrator needs to write file 3, he can. He just has to go out and he has to run SD program SD3. And then he can read and write file 3. So that's another really important pattern that you can use to solve these problems. Now, and then here's the third, I think it's the third and final pattern I have here. And I guess another thing I want to stress, too, is this sort of, not a lot of people use type enforcement. Secure Computing, the company I came from, they use it in their Sidewinder firewall, which is a commercial firewall that had great success with it. But they make a very static type enforcement policy. They don't have to engineer it anymore. They got it set up once, right? They analyze it. It's done. It's not a generic operating system where people are doing new applications to it all the time. I mean, they'll add a new filter and they'll put type enforcement in it to protect it, but it's a very rare event for them. So what's missing here is type enforcement engineering. Secure Computing has some expertise in it, and now that SE Linux is available, that expertise is out there and it's starting to grow a little bit. We've also seen some people do some very stupid things with type enforcement where they don't understand some of the powerful tools they have in their bag. That's why I'm going through all these patterns. So this third pattern here is wrapping untrustworthy programs. Say, for example, you have a policy where you don't want any words containing project names to go out of your company. Maybe it's the secret code name like Palladium, and you don't want anyone outside to know that. Well, if you had to analyze a POP client to make sure that it doesn't contain, no outgoing mail messages contain the word Palladium, you'd have a very large program to have to analyze it if you want to make sure that it's doing the job correctly. It's a lot of work. But you could write a very small program that looks at the body of the text of the messages or looks at the whole message and makes sure that none of the message contains Palladium. I mean, that could be a 30-line program, say. And so you could actually analyze it. You have hope of doing that. What you can do then using type enforcement is you could have the pop mail client work just like normal. The user uses it, the client application talks to it, and just as before it sends the data out, you make sure that it has to go through this little program you've written, and it does the filtering. And now you've got a high assurance system that's going to make sure that none of your sensitive words go out. Now that's sort of a contrived example, but that sort of shows the pattern of where you can maybe put a small program in front of something and increase the assurance. All right. Now, this is an example of SE Linux policy. This is having to do with the password file. And I really don't want to get into the language of the SE Linux policy language. Unless you're going to use it, it's not that interesting. But I just want to show you some of the things that are here. You have declare types. You then they make heavy use of macros. That temp domain password is actually a macro that expands into the ability to write to temp directories. And the bottom line there, where it says allow password type, basically what's happening there is you're declaring this is where the password file goes, and you're allowing this etc. type to actually relabel it, which is to change the label of it, a very powerful permission. And so, that looks sort of like a benign line, but that actually is a very powerful thing, and that could actually cause you to compromise the system unless it's configured correctly. Who can now do this becomes very important. And so I just want to show you some of the complexity of it. Even though it looks simple, there's a lot of things in here that have to be analyzed. So how do you know you have it right? That language I just showed you is really the equivalent of like C language. C without lint. So it's just like one notch above assembly language. So you don't have things like scoping, right? So if I have a file over here and I'm talking about the password file and I say, I only going to have this guy and this guy, they're going to be able to access it. Nobody else can access it. That's my policy. That's great. And you look at that file, that's great. Well, over here, somebody can say, I need access to the password file. I'm just going to give my guy access to it. So you know, in this file, it looks like everything's fine. You have to look at all the files that are combined in one big file to understand it. Now, we've created, at Tresys, we've created a tool called APOL that helps you it basically combines all those files and lets you run queries on the whole policy as a whole. I'll talk more about that in the end, but that's your only hope at this point, because without any scoping, anybody can touch any other file and you've got a problem. It's basically just like C. And so you've got all the problems of C, and you don't have any of the type checking of C, so, or of like a lint program. So more work is needed there. So if you think about it, the bottom line, one thing I'd like you to take away from this, if nothing else, is that creating security policies is hard. When we first started doing, security, 17 years ago when I started on it, we were thinking, oh, analyzing the system. We're going to analyze the operating system, make sure the operating system is secure. We're going to build all these layers. That's the hard problem. When we're all done, we'll just make the security policy, and it'll keep everything separate, and that'll be great. And as we go forward now, we're realizing that security policy is a significant piece of engineering that's hard. It almost approaches the complexity of software engineering. Because if you think about it, if you're going to do a true least privilege policy for each program on your system that's important, you have to know what resources does that program need, how does that program talk to other programs, how they interface. Maybe the program is grabbing a bunch of this greedy program bullet here at the end. Maybe the program is grabbing a bunch of resources. It's touching a lot of things. You'd be amazed at how many programs have the ability want to write stuff into temp that you never realized they did. And so you have to say, well, gee, it doesn't need to do that. I want to take that permission away because it's going to violate my security policy. So developing security policies is hard. There's a whole science of engineering there that becomes also merged with your software development process to not only develop the security policy, but basically change the software development process, making things smaller and more modular so you can analyze them. And it's a whole engineering that sort of, some of the people at Secure Computing, that I and the people at Tresys have sort of a gut feeling for, but we have to sort of build that into a science. One of the things with all this analysis you're trying to do is trying to avoid trusted processes. Because like, for example, when I talked about that labeler example, right? A very small program that you actually have a hope of analyzing. Well, for every program on your system you have to analyze, that causes you more work. Now that labeler example I used is very small. You'll find as you start doing a real system, especially if you're going into an existing system where there's already a lot of components and system components, there's a lot of existing software and it's thousands of lines long. Now how are you going to analyze that to make sure that that's doing only what it's supposed to do? I mean, you'd have to specify the program and then analyze all the code. It's very expensive. It's doable. I have a question personally if it's economically doable. And of course, that's what in a lot of the work going on here and around the country is trying to do, find economical ways of analyzing software to make sure that it meets certain requirements. So the whole goal then, is when the security analysis as I'm performing here, is I want to minimize the number of trusted processes. Because for every trusted process I'll wind up in my final system, then the cost of analyzing goes up. And as from a reality point of view, I also know that if the number of trusted processes gets too high, people start doing triage and saying, that's a trusted process, but I think it's okay. And you'll just kind of sweep it under the rug and nobody does analyze it, which, is hiding the security problem. But so it's very important then when you identify a trusted program, you have to know what it's trusted to do. Like that labeler program, the important thing there is that it labels the file correctly. And you'll think about it, I make sure it doesn't want to modify the data. That would be bad. Or that it doesn't keep state. So when the next file comes through, and maybe it's labeled correctly. So there's all kinds of things you'll have to analyze, but it'll be a small list, but you have to have that list to know what the program's going to do. The other thing that for each trusted program, and this is a problem I see in a lot of the systems I'm getting that other people have analyzed, is people won't control the executable for the trusted program.